Greetings, scientists. Today we're going to look at the properties of metal matter versus non-metal matter. And as we can see from the 118 elements that we have here on the periodic table, the majority of elements that we have are in fact metals, a minority of metals, and we do actually have a few that are somewhere in between in terms of our metalloids, but I'll leave that for a future YouTube. So why is it important to be able to distinguish between the properties of a metal versus a non-metal? Well, here we have a mystery space object flying into the Earth's orbit. And so what we need to be able to do scientifically is to be able to identify the properties of matter so that we can utilize these in terms of chemistry, in terms of industry, in a manner that can help not only bring humanity forward, but also the world at large forward. So there are 6 characteristics that we can use to distinguish between metals versus non-metals. Starting with number 1, malleability. So what we mean by malleability is the ability to change the shape of an object of matter without breaking it by using a force. Metals tend to be malleable. If we bash them with a hammer, we can change the shape of them. Think about some of the metals, some of the alloys that are in your kitchen, in your garage, etc. Non-metals are the opposite. And the opposite of malleability is whether it's brittle. So non-metals, when we tend to bash them, exert a force on them, they tend to break. The second characteristic that we'll look at is the density. How tightly packed the matter is in a given space. Given all non-metals, apart from bromine, are gas at room temperature, let's kind of not worry about liquid at this point. Let's just focus on gases versus solids. So metals tend to have a higher density. So what that means is the arrangement of the particles are a lot more tightly packed, very little space between them. Whereas your non-metals the particles tend to be more spread out, which is what we have with our gases here. Characteristic number 3, let's look at the object and determine how lustrous it is. So lustrous means shiny. Metals tend to be shiny when we give them a bit of a polish. Non-metals tend to be the opposite of that, which we call dull. The fourth characteristic is the object a conductor or an insulator? So if it's a conductor, then the object is very efficient at transferring electricity, efficient and quick. So the electrons in the valence shell of the atoms can easily hop across to the adjacent atoms and transfer the electrical charge, which is what we have with metals. Metals are good conductors. An insulator is the opposite. It's not good at transferring the electricity through that matter. Non-metals tend to be insulators, the opposite. The fifth characteristic is ductility. So something that is ductile can easily be stretched into wires. Metals tend to be ductile. That's why we use them in cabling. Whereas non-metals tend to not be ductile. We can't stretch them. If we try to, they'll tend to break. And the final characteristic that we use to distinguish between metals versus non-metals is the melting point. So at what temperature in Celsius in Australia will we basically get a change in the state of matter from a solid to a liquid? So with your metals, they tend to have a very high melting point. It takes a lot of energy to break apart those bonds that have it in a solid form to change it into a liquid form. Whereas your non-metals, and again, all non-metals apart from bromine, are gases at room temperature, they have a much lower melting point. So in summary, going back to the metaphoric space rock, we're trying to work out basically whether this mystery space rock is a metal or a non-metal So we come up with 6 sets of questions. They are dichotomous in terms of the answers will basically generate opposites. So metals tend to be shiny, which means they're lustrous. They tend to have a much higher density in terms of the arrangement of the particles. They tend to be solid at room temperature, which is around 20 degrees Celsius. They're good conductors of electricity based on the transfer of the electrons in the valence shell to the adjacent atoms. They tend to be malleable, so we can easily bend them and change them into shapes, into pots and pans. They tend to be ductiles, which means we can stretch them into wires. Your non-metals, which again, if we focus on them at an elementary level, are gases at room temperature, apart from bromine. They tend to be dull, they're not lustrous. They tend to have a much lower density in terms of the spacing of the particles within that given space. They can be solid or a gas at room temperature, except for bromine, the exception to the rule. They're insulators, they're bad conductors of electricity. They tend to be non-malleable. We can't bend them if we bash them, as is the case with whether we get, in terms of how brittle they are, they tend to break apart.